Now let us look at monitoring the performance of our layer 2 solutions. This includes assessing the performance of network equipment, switches and routers as well as the overall performance of the network. So performance monitoring helps identify bottlenecks, troubleshoot network issues and optimize network performance. By monitoring key metrics, network administrators can gain valuable insights into the health and efficiency of the layer 2 infrastructure. Here are some key performance metrics. So throughput, which is transactions per second. So throughput is a crucial performance metric in layer 2 solutions. It measures the number of transactions processed per second. Higher throughput indicates the network's ability to handle a large volume of transactions efficiently. Next comes latency, which is transaction confirmation time. Latency measures the time it takes for a transaction to be confirmed on the network. Lower latency is desirable as it indicates faster transaction processing times and a more responsive user experience. Next comes gas fees. Gas fees are the cost of processing transaction on a blockchain. They vary depending on factors such as network congestion and transaction complexity. Monitoring gas fees is important for optimizing costs and ensuring predictable transaction expenses. Next is security. So security is paramount in layer 2 solution. This metric assesses the network's ability to prevent fraud and malicious activities. It involves evaluating the effectiveness of fraud detection mechanisms and the ability to handle security challenges. Here are some tools for monitoring performance. So first is Etherscan. Etherscan is a popular blockchain explorer that provides comprehensive data about Ethereum transactions and smart contracts. It offers a range of monitoring tools, including real-time transaction tracking, contract auditing, and block analysis. We can use Etherscan to track the performance of our layer 2 applications and identify any potential issues. Next, Block Scout. So Block Scout is another widely used blockchain explorer that focuses on monitoring the performance of layer 2 solutions. It provides detailed metrics on network throughput, latency, and gas usage. Block Scout also allows us to visualize data in various charts and graphs, helping us gain insights into our application's performance. Next is custom monitoring solutions. So for more advanced monitoring needs, we can implement custom solutions. These solutions allow us to tailor monitoring metrics and dashboards to our specific requirements. We can utilize tools like Prometheus and Grafana for data collection and visualization, giving us complete control over our monitoring setup. Now let us look at setting up Etherscan for monitoring. First, we register for an API key. So Etherscan offers a free API key that allows us to access its data programmatically. You can use this key to automate data retrieval and integrate Etherscan into our custom monitoring systems. Then we explore transaction history. Etherscan provides a comprehensive history of transactions on the Ethereum blockchain. We can track transaction timestamps, confirmations, gas usage, and addresses involved in specific transaction. Then we can also analyze contract data. Etherscan also provides detailed information about smart contracts deployed on Ethereum. We can examine contract code, function calls, and contract balances to monitor their performance and identify potential issues. So as we can see, Etherscan is a valuable tool for monitoring layer 2 solutions. It allows us to gain visibility into transaction activity, smart contract behavior, and overall network performance. By leveraging Etherscan's data and API, we can identify potential issues, troubleshoot problems, and optimize the performance of our layer 2 applications. Next, we shall look at using Block Scout for monitoring. So Block Scout is a powerful tool for monitoring the performance of layer 2 solutions. It provides a wide range of features that can help you gain insights into a network's health and efficiency. Block Scout allows us to track key performance metrics like throughput, latency, and gas usage. We can also visualize data in charts and graphs, making it easier to understand trends and identify potential issues. So here is how you can get Block Scout for monitoring. This command. Now, first we shall access Block Scout. We shall start by navigating to the Block Scout website for our specific layer 2 network. This will provide us with a comprehensive dashboard to monitor our applications. Next, we shall explore its features. Block Scout offers a variety of features, including real-time transaction tracking, block analysis, and contract auditing. Next, we shall track metrics. We shall use Block Scout to track key performance metrics like throughput, latency, and gas fees. This allows us to assess your network's performance and identify areas for improvement. Then we shall visualize this data. So Block Scout enables us to visualize these data in charts and graphs, providing valuable insights into our network's behavior over time. Now let us look at implementing custom monitoring solutions. First is looking at setting up a monitoring server. To implement custom monitoring, a monitoring server needs to be set up. This server can be a dedicated machine or a virtual instance. It should be configured with the necessary software and tools. The next is using Prometheus and Grafana. So Prometheus is an open source monitoring system designed for collecting and storing metrics. It provides a flexible query language for data analysis. Grafana is a popular open source dashboarding tool that allows you to visualize Prometheus data. Next is the example setup. We can install Prometheus and Grafana on your monitoring server. Configure Prometheus to scrape blockchain data from a layer 2 network. Then use Grafana to create custom dashboards to visualize the collected data. Here is an example of monitoring with Prometheus. So Prometheus provides a flexible query language for analyzing and visualizing data. Here we can configure Prometheus to scrape blockchain metrics from our layer 2 network, giving us valuable insights into its performance. This allows us to identify bottlenecks, troubleshoot issues, and optimize our network. Here is how we do it. Next, we shall visualize data with Grafana. Grafana is a powerful open source tool that allows us to visualize and analyze data. We can install Grafana on a dedicated server or a virtual machine. Grafana provides a user-friendly interface for creating custom dashboards. Here, we shall be creating dashboards for key metrics. Grafana allows us to create dashboards that display key performance metrics like throughput, latency, and gas fees. We can configure different chart types such as line graphs, bar charts, and pie charts to visualize our data in an intuitive. Now let us look at monitoring transaction throughput. So first, let us understand transaction throughput. Transaction throughput, often measured in transactions per second, reflects the rate at which transactions are processed on a blockchain network. A higher TPS indicates greater efficiency and capacity for handling a high volume of transactions. Second is the monitoring techniques. Various tools and techniques can be employed to monitor TPS. Block Explorer, like Etherscan and Block Scout, provide real-time data on transaction activity. We can also utilize APIs and libraries to retrieve transaction data and calculate TPS. Here is an example JavaScript code snippet that demonstrates how to calculate TPS based on block data. The code here retrieves the latest block, counts the number of transactions, and calculates the TPS using the time difference between blocks. Now let us monitor transaction latency. Transaction latency measures the time it takes for a transaction to be confirmed on the network. Lower latency indicates faster transaction processing, leading to a more responsive user experience. Efficiently monitoring transaction latency is crucial for identifying bottlenecks, troubleshooting issues, and optimizing network performance. First is to measure confirmation time. We track the time elapsed between initiating a transaction and its confirmation on the network. We use timestamp based methods to record the start and end times of a transaction. Next, we utilize monitoring tools. We employ blockchain explorers like Etherscan and BlockScout to monitor transaction confirmation times. These platforms provide detailed insights into transaction history and latency metrics. Next, we shall implement custom monitoring. So for advanced monitoring, develop custom solutions using libraries and APIs to retrieve transaction data and calculate latency directly. Here is an example JavaScript code that demonstrates how to measure transaction latency by recording the start time and calculating the difference upon confirmation. Now we shall monitor gas fees. High gas fees can significantly impact the profitability of our application. So by tracking and analyzing gas fees, we can identify trends, optimize our transaction strategies, and minimize our costs. First, we shall track average gas costs. We shall monitor the average gas price paid for successful transactions on our layer 2 network. Then we shall analyze the gas usage. We shall examine the amount of gas used by different transactions and smart contracts. This helps identify potential inefficiency. Then we shall utilize monitoring tools such as Etherscan and BlockScout to provide real-time gas price data and transaction analysis. Then we shall implement custom solutions. We shall develop custom scripts or integrate APIs to retrieve gas price data and track it within our own monitoring system. So here in this JavaScript code snippet, we see how to retrieve the current gas price from the Ethereum network using the web3.js library. This code can be integrated into our monitoring dashboards or scripts to track gas price fluctuations and identify trends. So we shall monitor security metrics. First, we shall be tracking fraud proofs. Fraud proofs are essential for maintaining the security of layer 2 solutions. By monitoring the number of fraud proofs submitted, we can gain insights into the frequency of potential security threats and the effectiveness of our fraud detection mechanisms. Next is monitoring challenge periods. So challenge periods are crucial for resolving disputes and ensuring the integrity of the layer 2 network. Monitoring the outcome of challenge periods allows us to assess the effectiveness of our dispute resolution process and identify any potential vulnerabilities. Then we shall be analyzing security metrics. We shall be regularly analyzing security metrics, providing valuable insights into the overall security posture of our layer 2 solution. This analysis helps us identify trends, potential threats, and areas for improvement in our security protocols. Now let us set alerts for performance issues. Now alerts are notifications that trigger when predefined condition is met. They're crucial for timely responses to performance issues. Next, let us configure alerts in Prometheus. Prometheus uses alert rules defined in a configuration file. We can set thresholds for metrics triggering alerts when they exceed those limits. Next, we shall be configuring alerts in Grafana. Grafana provides a user-friendly interface for managing alerts. We can configure notifications to be sent via email, SMS, or other channels. So here is an example to configure alerts in Prometheus. Prometheus allows us to configure alerts that trigger when certain conditions are met. We can define alert rules in a configuration file specifying the expression to evaluate and the actions to take when the condition is true. So a common alert rule is to monitor transaction throughput. If the rate of transaction drops below a certain threshold for a specified duration, an alert can be triggered. This helps us identify potential performance issues and take corrective action. So here is the summary which is displayed through a notification. Here we can see how the labels are. So the severity of this alert is critical. Now let us look at setting up alerts in Grafana. So Grafana allows us to configure alerts that notify us when specific conditions are met. These alerts are triggered based on metrics collected from our layer 2 network such as transaction throughput, latency, or gas fees. We can set up thresholds for these metrics and Grafana will send notifications when they exceed or fall below those thresholds. To set up an alert in Grafana, we first need to create an alert rule. Alert rules define the conditions for triggering an alert. We can then configure notifications to be sent via email, Slack, or other channels. Grafana provides a user-friendly interface for managing and configuring alerts. Now, real-time monitoring is crucial for understanding the performance of our layer 2 solution as it happens. This allows us to react quickly to any issues that arise, preventing potential downtime or performance degradation. By tracking key metrics in real time, you can gain invaluable insights into the overall health of our network and make informed decisions. Now, we shall use WebSockets for real-time data. So WebSockets provides a persistent connection between the client and server, enabling real-time data updates. We can subscribe to events like new block creation or pending transactions, receiving updates immediately. Then we can also set up alerts that trigger based on real-time data, notifying us of any critical issues or anomalies. Here in this JavaScript code snippet, we see how we use WebSockets to subscribe to pending transactions on Ethereum. By subscribing to this event, we can receive real-time updates whenever a new transaction is submitted to the network. This allows us to monitor the transaction flow in real time, providing valuable insights into the current state of the network. Now, we have to analyze historical data. So, storing historical data is crucial for identifying long-term trends and patterns. This data can be used to improve decision making and optimize performance over time. Layer 2 solutions can benefit from storing data in time series databases like InfluxDB, which are designed for efficient storage and querying of time-based data. Next, using these tools for analysis, we can use Grafana to visualize and analyze the data. So Grafana provides a user-friendly interface for building dashboards that display historical trends, metrics, and other performance indicators. This allows developers to quickly identify areas for improvement and optimize the layer 2 solutions based on historical insights. Here is an example setup. So a common approach is to store performance metrics in InfluxDB and use Grafana to visualize and analyze the data. Grafana dashboards can display historical transaction throughput, latency gas fees, and other relevant metrics, providing valuable insights into the performance of the layer 2 solution over time. Now, we shall be optimizing the performance based on monitoring. So first, we should identify the bottlenecks. So monitoring this data helps pinpoint performance bottlenecks. These bottlenecks could be due to inefficient code, network congestions, or other factors. Analyzing data reveals these performance inhibitors. Then we shall implement optimizations. Once bottlenecks are identified, optimizations can be implemented. These optimizations might include code refactoring, network upgrades, or other strategies designed to address the bottleneck. Here is an example of optimization to reduce contract complexity. Complex smart contracts can increase gas costs. So, optimizing code to reduce complexity can decrease gas usage and improve transaction efficiency. Streamlining code minimizes computational overhead and improves performance. Here are some real world examples of performance monitoring. In the DeFi performance, decentralized finance applications often handle complex transactions and require rigorous performance monitoring. By tracking key metrics like transaction throughput, latency, and gas fees, developers can identify bottlenecks and optimize their protocols for efficiency and scalability. Real time monitoring helps ensure a smooth user experience and prevents disruptions in trading activity. In gaming, smooth gameplay relies on efficient transactions and low latency. Performance monitoring is crucial to ensure seamless interactions between players, asset transfers, and in game events. Monitoring tools can highlight areas for optimization, such as network congestion or code inefficiency, enhancing the gaming experience. Next is the NFT performance. Non fungible tokens are increasingly popular, demanding robust infrastructure for minting, trading, and displaying digital assets. Monitoring performance metrics helps optimize the NFT ecosystem, ensuring fast and reliable transactions, efficient marketplace operations, and a positive user experience for artists, collectors, and enthusiasts. Here are some challenges and solutions in performance monitoring. So, first is handling large volumes of data. Layer 2 networks generate massive amounts of data. So, efficient data storage and querying are essential. Time series databases like InfluxDB are optimized for this. Data aggregation and sampling techniques can reduce the volume while retaining crucial insights. Now, ensuring accurate and real time monitoring. Accurate data is crucial for informed decision making. Validate metrics against multiple sources. Ensure real time updates for timely responses. Use monitoring tools with low latency and efficient data pipelines for accurate real time insights. Next is implementing effective alerting and response strategies. Configure alerts to trigger on specific conditions. Define clear thresholds and response protocols. Integrate alerts with incident management systems. Automated responses can mitigate issues before they escalate. Consider manual intervention for complex scenarios. Here is the conclusion. So monitoring is essential for maintaining the performance and reliability of layer 2 solutions. By tracking key metrics, identifying bottlenecks, and implementing optimizations, we can ensure a smooth and efficient user experience. It's vital to stay updated on the latest monitoring tools and techniques as the landscape is constantly evolving. Regularly review and refine your monitoring processes to keep pace with the growth and complexity of our network.